LegalizeFreedom.com. Why are we here? Where do we come from? Where are we going? From the nature of reality to the future of humanity. Beyond politics, poverty and war. LegalizeFreedom.com.
Greetings and welcome once again to LegalizeFreedom.com. I'm your host Greg Moffat, and my guest today is geologist James Maxlow, who joins us to discuss the theory of expansion tectonics. In a startling challenge to conventional geology, expansion tectonics suggests that the Earth has not always been the same size. Hundreds of millions of years ago, it may have been much smaller, with vast implications for the past, present and future of life on this planet. A single supercontinent called Pangaea dominated Earth 300 million years ago. But whereas plate tectonics suggests that it existed surrounded by a huge super ocean, expansion tectonics suggests that it covered the entire planetary surface. As the planet expanded about 100 million years ago, so the spaces currently occupied by the great oceans opened up. Expansion tectonics offers a radical overhaul of many accepted ideas about the Earth. It can help explain patterns of evolution, how life spread across the planet, catastrophic mass extinctions, and mysteries such as how and when Antarctica could once have been lush, green, and free from ice. The theory, therefore, has great relevance to Earth changes that we are witnessing today. It also poses many fascinating questions. If the planet is expanding, where does the additional matter come from? What, if anything, can it tell us about the origins of the Earth? And is expansion occurring on other planets, in other galaxies, or even throughout the entire universe? With or without expansion tectonics, the Earth does continue to expand, although the rate, just a few centimetres per year, is stretched across such a vast timescale that it has barely registered since human beings first evolved. However, should it continue, life on Earth will once again be profoundly transformed during the next few million years. Hello and welcome, James, and thank you so much for joining us today on LegalizeFreedom.com.
Hi, Greg.
Now, today, James, we're going to talk a bit about the expanding Earth theory. Before we get into that, just tell listeners a little bit about your background and your work.
My background, work background and academic background is that I'm a retired professional geologist. I've been working in the mining and exploration industry throughout much of Australia for on and off 40 years, and during that time I went back to university to do a master's degree, and then soon after that I completed a PhD study on expansion tectonics.
Expansion tectonics is basically another name for what I said just a moment ago, the expanding Earth theory. This is going to be a new idea to a lot of people, I suspect, so just give us a brief summary of it. We're going to get into the detail of it, but just give us a brief summary of the theory and also the history of the idea, kind of where it originated.
A brief summary and history is that, yes, expansion tectonics builds on the historical expanding Earth, growing Earth, by using modern data, modern global data. When Earth expansion was first proposed in the middle of last century, this data was not available, and since then, of course, there's been a rapid growth in space technology, data gathering, computer science, and media studies, and all that sort of thing. Now, expansion tectonics, as I said, builds on that by using modern data, and I have to define expansion tectonics as a new science that explains the changes to the shape and size of the Earth. It is used to reassemble the various crustal plates on an Earth whose surface area increases with time, in sympathy with an increase in Earth radius.
Obviously, you've got your background to take into account, but what was it about this idea in particular that caught your imagination, so much so that, you've written a book on it and you do presentations, you've got a website devoted to it. It must have, fired your imagination and maybe filled in some gaps that you felt were in your knowledge.
My interest stems from probably the 1980s, early 80s, when I was working in the Pilbara region of Western Australia. My original degree in Melbourne in the late 1970s, basically we didn't study plate tectonics per se. It was more continental drift that we studied. So I didn't have a formal grounding on plate tectonics. So my ideas and observations in the field were not clouded by these plate tectonic requirements. When I was in the Pilbara is a huge domal structure, many hundreds of kilometres across, with a number of thousand metres of volcanic rocks and finely banded iron rocks. And this has been preserved for 2,500 million years in the ground. And it occurred to me at the time that this domal structure may represent a preserved piece of an ancient Earth, which was much smaller than the present radius of the Earth. At that same time, I started reading up on Professor Sam Warren-Terry's book called The Expanding Earth, and this took my imagination, and it gelled with what I was seeing in the Pilbara, the rocks and dome in the Pilbara, and it basically led on from there. I was never happy with plate tectonics per se, and my career throughout much of Australia enabled me to then develop my ideas along the lines of Earth expansion. And in 1995, I graduated with a master's, and my initial degree, master's degree, was studying global expansion tectonics. I've since reduced that. I've since now call it expansion tectonics, but that's when I first introduced the expansion tectonics to the world. And from there, I was allowed to then move on to a PhD study where I did a far more in-depth study on expansion tectonics, bringing in a whole host of different data in the geography, geology, geophysics, and biogeography, and was able to reconstruct the ancient Earth way back to the beginning of geological time, some 4,000 million years ago. Now, this has never been done for any tectonic study, and it still stands today as being the only study which has been able to model the Earth back to the beginning of geological time.
You mentioned plate tectonics, and that's the mainstream theory of how the world works. A lot of people will remember this from school, but perhaps we should just briefly say, for people who don't know what the competing theory, this plate tectonics, is, just how mainstream academia says that the world works.
Well, the fundamental difference between plate tectonics and expansion tectonics is that plate theory assumes that the radius of the Earth is constant, and from that, the continental crusts are modelled back in time on a random continental drift theory, which to me is, I call it a wham bang crash bang theory, where these fragments of crusts jostle around the surface of the Earth, crashing into each other, amalgamating again to form supercontinents, breaking up again, and it's just such a random process. Whereas, in contrast, expansion tectonics removes this assumption and simply allows the radius of the Earth to change with time. And moving back in time, each of the continents, in fact, very precisely reassemble together to form a complete crust which surrounds the entire Earth at roughly 50% of the present radius of the Earth. Well, that's the fundamental difference between plate tectonics and expansion tectonics, whereby plate tectonics, in plate tectonics, the movement of the fragments of crust is a random process, whereas expansion tectonics, the crusts reassemble back in time precisely at an evolving process.
Now, okay, this idea that the Earth was at one time a great deal smaller than it is now will strike people as bizarre until perhaps they've looked at some of your material and indeed referenced some of the earlier stuff that you mentioned. One question in people's mind will be, well, where does the additional material come from? You know, we think of biological organisms, for example, like you and I, we ingest food and we grow. So is the material being generated within the Earth?
No, the causal mechanism, and you're right, this the reason for this, for the expansion of the Earth has always thwarted past researchers, and it's always been thrown at us as this cannot happen because such and such and such and such cannot happen. And there's probably about 9 or 10 different ideas that have been proffered over the past 50 years as to how this mechanism, causal mechanism for growth in Earth can happen. Now, it's only been in the past few years that satellites have been launched to study the impact of the sun's activity on Earth's space environment. These satellites have been fly in formation around the Earth, and they collect three-dimensional information on how the sun's solar wind interacts with the Earth's magnetosphere and how it affects the near-Earth space and the space atmosphere, including the auroras. What this study showed is that incoming charged particles from the sun, comprising electrons, protons, and ions, had breached the magnetosphere, contrary to what has been previously thought. And this magnetosphere actually acts as a filter rather than a continuous barrier to these charged particles. The scientists considered this of great importance because they showed how the Earth's magnetosphere can be readily penetrated by solar particles. This study also suggested that this phenomenon is more common than was previously thought, and therefore represents a valid mechanism for the constant and ongoing penetration of solar particles into the Earth. So what is envisaged is that these charged particles, which includes electrons, protons, and other ions, from the solar wind discharged from the sun, these enter the Earth at the poles and recombine within the highly reactive D region located at the base of the Earth's mantle, directly above the core mantle boundary. The recombination of these charged particles within this region then provides a mechanism to form new matter. And this new matter, in turn, becomes the building blocks for all elements and mineral species present on and in the Earth today. From an expansion tectonic perspective, this accumulation of new matter within the mantle results in an increase in Earth's volume, which manifests itself as a swelling of the mantle. The increase in Earth's volume and its associated mantle swell is then transferred to the outer crust, where it gives rise to crustal extension, which is currently occurring as extension along the full length of the mid-ocean rift zones. Extension within these mid-ocean rift zones is accompanied by intrusion of basaltic mantle-derived lava, along with expulsion of new water and new gases. These in turn increase the surface area and volume of all of the modern oceans in strict accordance with the seafloor geological mapping. Now, this is the causal mechanism that I, in association with a number of researchers throughout the world, have come up with, and it is the favoured mechanism where the causal mechanism is an external accumulation of new material, particulate matter from the sun, that accumulates within the core mantle boundary, causing mantle swell, increases the volume of the Earth, and then this volume is manifested at surface as crustal extension, increasing the surface area of the oceans and allowing the rifting and migration of the continents.
This actually, from my layman's perspective, it sort of makes sense in a way, because we're always being told that, we're made of stardust and that the materials, organic materials that make up planets come from stars. Stars are these big, basically fusion reactors. So what then would that tell us about Earth's origins, for example? I mean, taking the mechanisms you're talking about, how might the genesis of Earth, what might that have looked like?
Yes, I do have thoughts on the origin of the Earth and Sun. In fact, the origin of the planetary bodies of the solar system. I'm not too sure how much detail I should go into it here, but during what I call the pre-Archean, the Archean commenced 4,000 million years ago. This is the known geological ages of the Earth that we know today. So during the pre-Archean, times before the Archean, it is considered that the Earth-Moon system was combined as a single glowing incandescent planet. Now, the reason why I say this is that the mechanics of the solar system also suggest that the Earth was much closer to the Sun, so therefore the Earth-Moon system was much hotter, and similarly the other planets as well. Now, what I'm saying here is that the Earth-Moon was combined as a single Earth-Moon planet at that time. And at that time, of course, the age of the known universe was only 3/4 of the age of what it is now. Hence, galactic conditions may have been vastly different to what they are now. With this in mind, it is envisaged that sometime between around 4,500 and 4,000 million years ago, the outer layer of this primitive glowing incandescent Earth-Moon planet was stripped off during a period of gravitational instability. And this gave rise to a binary planet system. So the Earth-Moon system that we know of now is a binary planet system. At that time, both the Earth and Moon were of a similar size. And since then, the weakly magnetic Moon has undergone minimal increase in radius, while the strongly magnetic, highly reactive core and mantle of the Earth has undergone an exponential increase in radius over time. And again, this is like the causal mechanism. This is speculative and goes against what conventional cosmology and science is currently telling us. But I present this as another mechanism, another somewhat speculative process to explain the origins of the Earth-Moon system. Moving back beyond that again, you're moving to the origins of the Sun, the origin of the galaxy, etc., etc. So that's moving far too far back in time for expansion tectonics.
Well, I think actually when you start to look at a lot of astronomy and astrophysics, you realise how much of what's in, university textbooks is actually speculative when it comes right down to it.
That's right, and that is the basis of science. The basis of theoretical physics and science is speculation. Speculation built on speculation is not true science.
No, there has to be, it has to be sort of tested theories, doesn't it? I mean, if a theory can't be tested, then it might be able to be tested in future. It's not that it's not useful. It might lead you on to another idea that can be tested, but ultimately it has to remain what it is, a theory.
That's exactly right. And the thing with expansion tectonics is now with this modern, in particular with the modern seafloor and continental geological mapping, it can be tested. the ancient radius of the Earth can be measured accurately, and models of the ancient Earth can be both mathematically and physically modeled to a high degree of precision. And the related sciences such as paleomagnetism, which is used to locate the position of the ancient poles on the Earth system. These can be precisely located on the scale Earth models that I talk about. So we've gone beyond speculation about expanding Earth, and now we're into the physical quantification of an expansion tectonic Earth theory and system.
What you said about the moon is actually very interesting in the context of how things currently are on the Earth-Moon system, because as I understand it, obviously the moon has a quite profound effect on the Earth, on the number of living systems, and that life on Earth couldn't be exactly what it is now if it wasn't for the presence of the moon.
I'm not too sure if the moon had anything to do with the origin of life on the Earth, except that the moon itself, of course, has a tidal influence, and in the past has been much stronger than what it is now, a strong tidal influence on the Earth. So that tidal influence has affected the seas and ancient oceans, of course, sloshing about and affecting the advancement of life forms in that nearshore little environment.
You mentioned the seafloor a couple of moments ago, and if people think back to geography in school, if you think of a profile of continents and the sea, you're coming along on the land and then it dips down sharply or maybe gradually down, you've got the sea, then you're along to the next bit of land, up again, just like a saucer or a basin. Even though but still the idea is that this is one crust. It may be made up of plates, but it's one crust. But actually, you've indicated that there are quite profound differences between the age of these rocks, i.e. the ones that would make up the continent and those that are on the seabed.
That's correct. There is a fundamental difference between the continental crusts and the seafloor crusts. Now, the seafloor crusts are essentially the lava called basalt, and central to all of the oceans, all of the major oceans, there is a rift zone called the mid-ocean rift, and along this mid-ocean rift, new basaltic lava is being continuously erupted, and as the oceans widen, this mid-ocean rift cracks again, periodically cracks, infills with new lava, it extends again, rifts apart, fills with lava continuously over 200 million years. Now, most of the oceans are, the Atlantic Ocean, for instance, that's increasing, that's spreading apart by around about 2 to 4 centimetres per year, and the East Pacific, that's around about the 12 to 14 centimetres per year. So all oceans are in fact increasing their surface areas, and there's an addition of new basaltic material along these mid-ocean rift zones. Now, this mapping, this seafloor mapping that I talk about, they've used very sensitive instruments that record the magnetism, the preserved magnetic signature of these basaltic rocks. And basalts have a high percentage of the mineral called magnetite, which is a magnetic mineral. And by sailing ships at a regular pattern across all of those oceans from one side to the other, they were able to detect and plot a regular systematic stripe-like pattern of alternating alternating magnetic patterns, which represented the shift in the north and south polar orientation. And from that, and subsequent to that, they've also gone along and taken samples of the seafloor at regular patterns across each of the oceans, and from these samples, by drilling into the seafloor, from these samples they've been able to age date the seafloor, either by radiometric age dating of the actual lava itself, or using the nanofossils that's preserved in the sediment sludge that's overlying the seafloor. So the outcome of this is that the magnetic mapping, geological mapping of the oceans, shows a regular parallel growth pattern to all of the oceans. So the rocks closest to the mid-ocean ridge represent the youngest rocks, with the most recent rocks which are currently being injected along these rift zones, and the ages then progressively age away from this mid-ocean zone towards the continents, and the volcanic rocks adjacent to the margins of the continents are shown to be the oldest, and they're consistently Jurassic in age, around about 165 to 170 million years ago. Now, this is a fundamental mechanism that I used in Expansion Tectonics to then, firstly, to measure. I measured the surface areas of these patterns, and from that I was able to then calculate an ancient Earth radius against time. So I calculated the ancient radius for each of the periods and epochs back to the Jurassic period. Now, from that, I was then able to construct accurate scale models of the Earth, and on that, I then used the geological mapping to reassemble the distribution of the ancient continents and oceans. And this was done by progressively taking away the various coloured stripes, age stripes shown on this map, and refitting the plates back together like a spherical jigsaw puzzle. A relatively simple process, and it really needs visual aid to fully explain it, but this has not been available prior to the 1990s when it was first published. So my predecessors, the Earth expansion predecessors, were basically running blind. That they could only assemble these continents with a visual fit together without being able to quantify it with the mapping. Myself and our colleague Klaus Rohl from Germany are the only two people in the world who have actually used this geological mapping to accurately constrain the assemblage of these continents back in time.
Now, you mentioned a moment ago the Jurassic, and that's going to ring a bell with people in connection with dinosaurs. This process, whatever else we've learned about the history of life on Earth, this process must have had a profound effect on it.
Oh, definitely. And I mentioned the Jurassic because that is the oldest seafloor crust that's been measured for each of the oceans. Around the margins of pretty well all of the continents on Earth today, the continental shelf is covered by sediments eroded from the land. So these sediments, in effect, cover the edges of the seafloor basaltic lava. So when you move back in time, you're actually reversing geology. So sediments eroded downstream and deposited in the oceans. When you move back in time, you actually have to then move this material back to the lands where they came from, and empty these mud, these basins around the edge of the continents. So by doing that, you then move into the Triassic period, which is between 200 to 250 million years ago. And by doing that, you can then, each of these continents actually lock together precisely without any volcanic seafloor crusts. And that is roughly the time, or the Permian period just prior to that, was roughly the time when dinosaurs first evolved from the more ancient creatures. And the influence that on the dinosaurs has been, well, during subsequent breakup of these continents and opening up of the oceans, of course, has been to force these dinosaurs to migrate into more favourable areas over an extremely long period of time, of course. The other interesting thing, while you're on dinosaurs, subject of dinosaurs, as Stephen Hurrell has pointed out, gravity during that time was about 50%, about half the gravity of what it is now. And Stephen will elaborate on that, of course. And that can be readily calculated by the volume and mass that you can determine from that ancient Earth. So with a gravity half of what it is now, of course, then you enable these huge, monstrous dinosaur species to have long necks and long tails and whatnot, and move around quite comfortably. But it's interesting to also note that on an expansion tectonic Earth, as you move from that moment in time, as you move forward in time, the surface gravity gradually increases to what it is now. And by the end of the Cretaceous period, the end Cretaceous extinction event, about 65, 66 million years ago, gravity was around about 2/3 to 3/4 of what it is now. So what I'm alluding to is over that 100 to 150 million year time interval, gravity has increased. So it's logical to also think about how did these supergiant dinosaurs die out early, or did they die out later? And were the later species smaller than the original giant species, and so on and so forth? I haven't studied that, and it would be a valuable research project.
Well, you mentioned Stephen Hurrell, and I'll just mention to listeners now that if they're interested in what you've just been saying, Stephen will be on with me next week. We'll be talking about all of this at length. That show will be going out between Christmas and New Year, so if you had enough turkey, that'll give you something to be getting on with. The question of the poles, north and south, within this expansion tectonics theory, do they remain in the same place, or I watched some of your animations, is it just a case that the different continents, as the Earth expanded, kind of the poles found themselves in different continents as we would know them today? Pole might have been in Australia at one epoch, and then in Antarctica the next, etc.
Yes and no. The poles remain in the same position throughout time, and the beauty is plotting the published paleopole, the ancient pole data. There's an international database of pole data information that you can access. When you plot this on models, expansion tectonic Earth models back in time, the poles actually plot what I refer to as diametrically opposed north and south poles. In other words, the measurements, the published pole locations actually plot as clusters at the top and bottom of the Earth, exactly where they should be. Now, when you mean those clusters, the north and south pole, the ancient north and south pole, you can then plot the location of the equator. And moving back in time, you can do this for all of the models that I constructed, the total of 24 models, in fact, and you can plot this information, and it does exactly the same thing for each model. It plots a diametrically opposed north and south poles. Now, this is a physical impossibility in plate tectonic models. In fact, plate tectonists basically only use the North Pole. And this is a bit of a misnomer because we have a North and South Pole. They can only use the North Pole to aid them in assembling the locations of continents and supercontinents on plate tectonic models. But on an expansion tectonic Earth, you get the diametrically opposed North and South poles. Now, getting back to your question, as the continents break up and rift apart and the new oceans gradually infill on those continents, moving forward in time, the poles stay the same, but it's the continents that migrate, and it's an apparent migration. For instance, the South Pole was originally located in central West Africa for around 96%, 3,750 million years, the first 3,750 million years of Earth's history. And once the Pangaea supercontinent started to break up, that pole, there was an apparent migration of the pole south to South Africa. In reality, it was Africa moving north. And then that South Pole did an apparent migration across the opening Atlantic Ocean, and then Antarctica migrated into the South Polar region, and the pole was established, pole and ice cap was established on the South Pole as we know it now. The North Pole was located in what is now North China, Mongolia region, and it's basically like the South Pole. It stayed in that location for 3,750 million years. Then, when Pangaea started to break up, the northern continents only moved apart a little bit. That's distinct from the southern continents, where there was a huge opening of the Southern Ocean, a huge opening of the Pacific Ocean, etc. The Arctic Ocean opened up during the Cretaceous period, around 100 to, say, 66 million years ago, and then remained there. So the pole actually just did an apparent migration from North China across into the Arctic Ocean region now, and has stayed there ever since. So yes, the poles stay stationary, because that's the same as your geographical rotational pole, and it's the continents that actually migrate. It's the apparent migration relative to the pole.
Forgive me if you've already done this and I missed it, but just for the sake of a glossary for people if they don't know, you mentioned the name Pangaea. That again may not be familiar to folks.
Pangaea is the name of a supercontinent, and in plate tectonic studies, it's the assemblage of all of the continents as we know them today together on a present-day radius Earth. So you actually only get these continents assembling together to form a single continent with a huge inferred ancient ocean called the Pangaea Ocean. On an expansion tectonic Earth, Pangaea is a time when the same continental crust, the same continents existing on Earth today, all assembled together to completely cover the entire Earth with continental crust. And at the time, there were no oceans, only a network of remnant continental seas. Now, it's these seas that then, and Pangaea, that assemblage of the entire modern continents on a smaller radius Earth is the same. It's Pangaea. It's called Pangaea, and these assemblies are basically roughly the same as plate tectonic studies. However, it goes one further and it completely closes off all of the crusts to enclose the entire Earth with crust. Now, at that time, we also hear of supercontinents called Laurentia, which is a northern continent, Gondwana, and some minor continents at that time. And now these supercontinents were actually defined by the network, this network of shallow seas, the shallow continents, to seas that I mentioned. So these shallow continents, seas that then subdivide Pangaea into smaller supercontinents called Gondwana and Laurentia and Laurussia and Laurasia and so on.
Now, for the sake of the discussion, let's assume that mankind evolved, humankind, I suppose I should say, in this day and age, evolved from apes, suddenly went onto 2 feet at some point. In that time scale, and obviously, again, there's much discussion and debate about what happened when, but given the enormous geologic amounts of time we're talking about here for this all to happen, is it likely or possible that any meaningful change in the size of the Earth took place while there were bipedal apes or whatever, or is it just way too far back in the past for that to be possible?
It's basically too far in the past, but there has been changes. There's constant change. The size of the Earth currently increases by 22 millimeters each year. So you can do your sums there, and it is actually quite considerable. But the distribution in expansion tectonics, you're talking about millions, it's tens of millions to hundreds of millions of year time spans. And of course, mankind and evolving from the apes, etc., only represents, say, the past few million years. And prior to that, you're starting to get into more primitive species, leading much further, thousands of millions of years ago, into bacterial types of single-cell life forms. So while the breakup of the Pangaea supercontinent and opening up of the oceans has influenced life in general. For instance, the plant species is a classic example of that, of how that breakup can influence the distribution of those species. And another good example is the distribution of carbonate reefs, such as the Great Barrier Reef in Australia, for instance. Now, the breakup of continents during breakup of Pangaea effectively introduces barriers, and these barriers can be seaways or changes in climate because the continent is actually migrating, say, for instance, from an equatorial location into a colder climate. So the species, say, coral species, which like nice warm waters, must continuously migrate, or subtly migrate over an extremely long period of time and remain in these warm water areas. And similarly, plant species, they're continually being forced, being moved into different climate environments. And if that species cannot keep up with the change, again, it's operating over millions of years. If that species cannot keep up, it will either have to evolve to something else more suitable, or it will die up and become extinct. And similarly, you get species, Australia, of course, is the classic example with the mammals, where it's been isolated as an island continent for many millions of years. So those species are landlocked and have no contact with its ancestors distributed elsewhere in the planet. So you get a shift in the evolution of those species, and hence now we get a complete contrast between, say, mammals and other species from around the world. and tree and plant species, of course.
Well, I mentioned actually the human dimension in this because when I watched one of your presentations, and several times I was reminded of things that are sort of sound a bit like things that have survived in myth. The idea that Antarctica was once not under hundreds of feet of ice, etc. And of course that is entirely possible, but again, there's no way that could be handed down, in the human tradition. But there would have been profound effects then on the climate in different locations, because many of us will think of at the poles, north and south, it's just always been cold, whether we were in the middle of an ice age or whether we were in the time of the dinosaurs when things were very hot and sultry. Nonetheless, it would be colder at the poles, warmest at the equator, and that's just the way it's been. But with the land mass breaking up and moving around like this, moving out, I should say, that will have caused many different conditions in different regions over all that period of time.
That's correct, and it's a very good point. And the classic example is Antarctica, as you hinted at. For much of the history of Antarctica, I'm talking about, say, 3,800 million years, its first 3,800 million years, for instance, Antarctica actually straddled the equator. And the South Pole, as I mentioned earlier, was actually in Central West Africa. Now, and that's an important point to note, because here in Australia we're constantly bombarded with our rainforests on the east coast of Australia. These are Gondwanan rainforests, and we are told that because Antarctica also has the same tropical species, plant and fossil animal species as Australia and South America and parts of New Zealand. And then in conventional plate tectonic thinking, they put two and two together and come up with five, in that therefore Antarctica was always on the South Pole, so therefore it must have had a warm tropical climate at some stage. Now, that's not how expansion tectonics works. Expansion tectonics uses modern mapping data to precisely locate where these continents are. As I mentioned, the physical data, the paleomagnetic data, precisely locate where the poles are, and from that, the equator. And as I said, Antarctica and also Eastern Australia, and at that time, Australia was rotated around in a north-south axis. So Western Australia was actually in the northern hemisphere, and the eastern and central parts of Central Australia were actually straddled the equator, and adjacent to that was South America, and below that Antarctica. Now, so hence we had these tropical species all evolving and developing, and once the Pangaea broke up and the continents started to migrate away as the radius of the Earth increased and the surface area of the oceans increased in sympathy, then Antarctica did an apparent migration south from the equator, south into the South Polar region. And it was only then that the South Polar ice sheet started to develop, and of course it killed off all the plant and animal species. And the South Pole at that time, prior to 200 million years ago, was located in Central West Africa, as I mentioned. During breakup, the South Pole apparent migration south to South Africa, and at that time there was an established ice sheet over Africa and parts of South America. Now, when it then crossed the coastline onto the opening Atlantic Ocean, the warm seafloor currents melted the ice sheet. It had already destabilized by then, had melted. So you get an increase in sea levels because the ice sheet at that time would have been a seasonal ice sheet, much like the Arctic is now. And so increased sea levels, change in seafloor, warm seafloor currents, and of course that would influence the sea levels throughout the world, the distribution of plant and animal species, and by around about, say, maybe 25, 40 million years, I think it was around about 40 odd million years ago, the South Pole, Antarctica had migrated into the South Polar region, and the pole started to wander onto the Antarctica, and as I mentioned, then it started to form a new ice sheet, hence the lowering of the sea levels, destabilization of plant and animal species, and affecting the climate, the ancient climates and sea temperatures, the distribution of marine species, and so on. So it actually influences the climate and ice sheet distribution quite markedly throughout time.
So it's possible then that this effect could have had an influence on mass extinctions that have appeared in the past. A lot of people think dinosaurs died out. There was probably a comet, and in effect there was a nuclear winter, etc. But of course they died out over a very long period of time. And in the last days of the dinosaurs, the number of species have been reduced quite drastically. So, just to reiterate, could this have had an effect on mass extinctions?
Yes, it certainly did. There have been basically 5 major mass extinctions since the early Paleozoic, since the Ordovician, certainly the end Permian, end Triassic, Cretaceous, and there's another one somewhere along the line. And these all coincide with relatively rapid changes in sea level. I'm talking about over 10 to say 20 million years. Now it's well known, well documented that each of these extinction events they don't happen instantaneously as we are led to believe. They happen over 10 to 20 million years. And the end Cretaceous KT extinction event, which supposedly resulted in the extinction of the dinosaurs, coincides precisely with when Antarctica and Australia broke up and rifted apart over a period of about 8 to 10 million years, which is the precise time frame that this extinction event occurred. And it's important for listeners to understand that dinosaurs just didn't just die off there and then at that moment in time. They had been evolving and changing and changing over hundreds of millions of years, and studies have shown that the time frame of a species and dinosaur genus is around about the 1 to 2 million years. So a particular species or genus evolves and becomes established, and then dies off or changes and evolves into something else, slightly different form over this 1 to 2 million year time frame. So by the time you get to the end of the Cretaceous period, 65 million years ago, there weren't very many dinosaurs left anyway. And as these dinosaurs, with this breakup between Antarctica and Australia, and I'll just backtrack a little bit there, in that prior to that time, there were actually 2 major oceans. One of which was the Pacific Ocean, the more primitive Pacific Ocean, and the other one was was the Atlantic plus Indian Ocean. They were all completely landlocked, they were completely separate from each other, and they had completely different sea levels, currents, marine species, and so on. And when Australia and Antarctica were breached and started to rift apart, these two oceans then re-equilibrated. The sea levels re-equilibrated. So one went down, and may have been of the order of, say, 100 metres. One went down, one went up. And I suspect it's the combined Atlantic-Indian Ocean that went down, and the Pacific Ocean went up. And it caused, over that 8 to 10 million year time span, it caused the extinction of these species that favoured the near-shore environments of the continents and oceans. So you get a change in sea level of, say, 100 metres. That's up or down. You get one side of that one ocean going up by 100 metres and the other oceans going down by 100 metres.
Just a brief aside, because there's not a great deal we can say about other planets not having been there, but is this, in your mind, is this a solar system-wide, maybe even galaxy universal? It's possible that this principle applies everywhere?
In theory it is, of course. Now the difference between the Earth system and most of the other planets, or certainly the inner rocky planets of the Earth, is that the Earth is what I call a wet planet. And by wet planet, it's got oceans and it's got atmospheric gases. Now, you can project the rate of increase in Earth's radius forward in time, and project the mass forward in time, and by around the 300 to 500 million years in the future, the Earth will be roughly the size of the giant planets Jupiter and Saturn. And at that time, it's envisaged that the Earth will be enveloped with gases similar to the lighter gases similar to these giant planets. Now, the inner planets, the rocky planets, they don't appear to have, they're certainly not wet planets as I talk about. They appear to be dry planets, so there's no means to form oceans and atmosphere as we know them in Earth.
So basically you don't want to be around here 300 million years from now?
Oh, we will certainly have evolved into something completely different by then.
Yeah, I suppose over that sort of time scale, if life can survive, then, it will. We've seen that certainly with the past then, haven't we?
Yeah, definitely, yes.
And you say this expansion tectonics is not a new idea. It has a history. What in general is the sort of mainstream scientific reaction to this? I mean, have there been people who've been within the establishment who've taken a serious look at it? What's the reaction been? Where is the current dialogue? I mean, I wonder what people like NASA say about this, because you mentioned about Earth expanding. I read something on their website about this, being preposterous, and you're saying, was it 22 millimeters perhaps? And we already have the poles shifting such that, airports are having to recalibrate landing systems and stuff because the poles have shifted sufficiently now that it's actually showing up as a visible, inaccurate measurement, at airport landing strips.
Mainstream science rejects anything to do with Earth expansion. And basically the argument is that it has been there has been no causal mechanism put forward in the past to convince them otherwise. So in their minds, it has been rejected, so it remains rejected, regardless of what new evidence and new data and so on, new systems has come to light since then. And this rejection is really, it's an emotive rejection, because it actually dates back to the 1950s and 60s, 50 and 60 years ago, time before modern computers, for instance, before space technology, before global data gathering and processing. So really this emotive reaction has influenced science from then on. If you mention anything to do with Earth expansion, there's immediate reactive rejection. And when you think about it, it's equivalent to, the expansion tectonics is equivalent to 500 years ago when Copernicus turned around and said to the scientists that, hey, the Earth is not the centre of the universe. Everything, well, certainly the solar system revolves around the sun. It's only the moon that revolves around the Earth. So getting back to expansion tectonics, it's on a par with that. And the conventional science are reluctant to change. They prefer to continually force observed data to a fixed static radius Earth premise, and without considering that this might be wrong. In fact, if this premise, this assumption that the Earth radius has remained constant with time, if this assumption is wrong, then everything to do with plate tectonics is definitely wrong. And that's where expansion tectonics steps in and says, hey, modern data is actually showing that the Earth radius is actually increasing with time, and all modern data actually fits better on an Earth that is increasing in radius with time. Now, getting back to the second part of the question, is that the Earth radius is increasing by 22 millimeters per year. The actual circumference of the Earth is around about 140 millimeters per year. So over 100,000 year time frame, then it mounts up to be quite considerable. And it's interesting, sea level changes throughout the world. There has been a consistent lowering of the sea levels by around about 2 to 3 meters. Everywhere you go, you see evidence of lowering of the sea levels. And basically, this is in context with the increase in Earth radius.
So if we're witnessing rising sea levels now, that's probably just a short-term effect due to, warming of the atmosphere and some of the ice melting.
It certainly is a short-term phenomenon. We digress here, but what the scientists don't tell you is that actually we are actually at the near peak of sea level rise, and there's the historical records of 1,000 years ago, for instance, it was 3 meters higher than what it is now, and that was the absolute peak, and there's been a number of these peaks, similar peaks in sea level at around about the 100,000 year interval, just off the top of my head. So what I'm alluding to is what archaeology, for instance, shows is that sea level now is actually about 60 meters higher than it is actually its mean sea level. So over the thousands of years of time frame, the sea level has been 120 meters lower than what it is now, and it has been 3 meters higher than what it is now. We're at just another little tiny blip at the top of that peak that is increasing. So I'm not sure if I should go into too much information there, but the sea level rises that scientists talk about will only be around about the 3 meter type dimensions over, say, 1,000 years.
Well, James, as we round things off for today, just a closing thought. I mean, what you said about the possibility of this principle operating elsewhere, maybe everywhere, it has some pretty mind-blowing implications about the future of the solar system, the galaxy, and the entire universe. If it was operating along those lines, I reflect on the fact that we're told that, everything is moving away from everything else in the universe, and it would just, I don't know, it really puts things in perspective. It's mind-boggling what we could imagine that, life in the solar system and elsewhere could be hundreds of millions of years from now.
Yes, it certainly is. And it's an interesting point, because if you're familiar with expansion tectonics, you can actually see expansion tectonics in operation on other planets and moons in our solar system. And the evidence is everywhere. But because NASA, for instance, are so fixated on plate tectonics, they spend billions of dollars a year in research funding to promote plate tectonics and all the everything to do with it each year. And so they're actually looking for a plate tectonic scenario on other planets, and are actually failing to see the expansion of these planets, the cracks and the rift zones and whatnot that are blatantly obvious on each of these planets and moons.
James, you've published a book on this subject. Share details of that with listeners. Also, your details of your website and just anything else you'd like to put out there.
Yes, I have two books. One's called Terra Non-Firma Earth, and my most recent book is called On the Origin of Continents and Oceans. And both of these, you can access both of these through my webpage at www.expansiontectonics.com. There's links there to purchase my first book, which is basically a small summary of my second book. The Origin of the Continents and Oceans is now available through Amazon, and again, there is a link on my webpage which will direct you to there. There's also, in my webpage, I also have a number of YouTube conference videos on show, and some free stuff with maps and diagrams that I need to get out to the public, as well as quite a comprehensive dialogue on expansion tectonics in general.
Well, James, thank you so much for joining us today on legalizefreedom.com.
Okay, thank you very much, Greg, for having me there. It's been a pleasure to talk to you and your audience. Thank you very much.
Well, folks, that's it for another week. As ever, thank you so much for listening. If you enjoyed the show, check out the website, which is legalizefreedom.com. That's legalize-freedom.com, where you'll find an archive of programmes offering alternative views on a wide range of topics, including politics and economics, energy and environment, culture, spirituality, history, and the nature of reality. You can also browse and buy a range of publications from our guests, and if you're feeling generous, make a donation to help keep the site up and running. Based on current audience numbers, if everyone who tuned in donated just 5 pence per show, that's about 8 cents US, this could become a full-time, fully funded operation, offering more and more often. During October 2014, over 50,000 of you streamed or downloaded at least one show. Total donations were £7 UK, which currently converts to about $11 US. Whether you listen, donate, or do both, I greatly appreciate your support. Until next time, I'm Greg Moffat, and you've been listening to legalizefreedom.com.